So our today's topic is 2PL, two-phase locking protocol, also known as concurrency control protocol. Okay, it ensures serializability, concurrency. It prevents conflict and ensures that the result of executing transactions should run concurrently. There are mainly two phases in 2PL. Okay, first one is growing phase and second one is shrinking phase. In growing phase, a transaction can only acquires lock. No transaction can release lock. Okay, if a transaction is acquiring lock, in between the acquiring lock, it cannot release lock, and it continues till the locking point is can get. Okay, what is locking point? We can discuss further. Okay, now the shrinking phase. In shrinking phase, all the transaction can do is can release lock. No one can acquire lock. Okay, it ensures serializability but does not prevent cascading rollback. Now we can understand by using the graph. This is a graph. Okay, now in this graph we have this as a acquiring lock. Here the point is acquiring lock. Okay, this is the locking point, or the corners of the point of locking phase is known as locking point, and this is a releasing lock. Okay, this phase is known as growing phase where we are acquiring lock. This phase is known as releasing phase or the shrinking phase where we are releasing lock, and this is locking point where we lock for doing some read and write operation. This is known as locking phase. Okay, now how it ensures serializability. Okay, let's suppose we have two transactions T1 and T2, and now we have transaction T1 as read A. Okay, now T2 will write A as A plus 30, which becomes 40. Now T1 equal writes A also as T1 read A as a 10, then it write A, so A plus 10, 10 plus 10, which is 20. Here what will happen, the write of A is not read by B because T1 already read it, this thing. Okay, so here when commit it should be 50, but due to conflict it is only showing 20. This is without 2PL, but when we are doing this with 2PL, T1 acquire lock, T2 tries to take lock, but as T1 does not release lock while acquiring because it is a growing phase, so T1 can acquire the right lock, it write the operation, it becomes 20. Then T1 release the lock in the releasing phase, then only T2 acquire the lock and can do the right operation as A plus 30. Now it becomes equals to 50, 20 plus 30. This is how 2PL ensures serializability and reduce the conflict between them. Okay, now talking about these two types of 2PL, which is strict 2PL. Now we will discuss about strict 2PL and rigorous 2PL. Strict 2PL is a stricter version of 2PL where we can release only write lock after commit. Okay, before commit we can release only read lock, after commit we can release write lock. It ensures serializability and recoverability. In rigorous 2PL, we can release both read and write operation after the commit. Okay, we can release read and write lock after commit. Before commit we can't release any type of lock. It ensures serializability, recoverability and strictness. Okay, that's all for today. Thanks.